Hello, all of my beautiful people. We are starting Unit 2, so that's super exciting. Unit 2 is all about parallel and perpendicular lines. And then Lesson 1, so 2-1, is specifically all about parallel lines, okay? So our objective for this lesson is by the end of this lesson, I will determine the measure of angles formed when parallel lines, so we're going to fill in the blanks here, when parallel lines are intersected by a transversal. And we may or may not know what a transversal is yet, but that's okay because it's one of our new vocabulary words, so we're going to go ahead and define it today. So lots of new vocabulary. We got going on. We have transversal, corresponding angles, alternate exterior angles, alternate interior angles, parallel lines, and I actually think that there's a couple more that we're going to look at too. And then theorems and postulates, same side interior angles, alternate interior angles, corresponding angles, and then alternate exterior angles, and we're going to look at what all of that stuff means. So what we're going to do first is we're going to go through all this vocabulary, all of the theorems. So at the very back of this packet, in that sheet that says terms, we're going to go to that sheet and we're going to fill in all of the vocabulary that we need for this lesson. All right, so here's our sheet of terms. So we're going to start with defining what are parallel lines, okay? So hopefully this is a review, but parallel lines are lines that never intersect or touch each other, okay? And then this is really important. They have equal slopes, so they have the same slope. So a diagram here, if I have a line, so there's my beautiful line, super straight. And if I have another line, if these lines are parallel, what we do is we use a little arrow symbol on the line, and I tend to do 2, but you can also get away with just 1. And if those arrows are pointing in the same direction, then the lines are parallel. So in this case, even though I drew it and they're probably not actually parallel, because I drew these little arrows, that's telling whoever is looking at this diagram that these lines are parallel, okay? So we can make a little note of that. So we use these little arrows on lines to show they are parallel. Okay. And then the symbol that we use for parallel is just 2 vertical lines. So if this line, I'm going to get another color going here. If this line was line M and this line was line L, I could say that M is parallel to L. So that's how we would write it, right? M and then our 2 lines parallel, and then L is this line. So hopefully that's all good. We're going to skip perpendicular lines because that's something that we're going to look at in our next unit, or in our next lesson. And I just looked and I'm wrong on that. So just kidding, we're going to do perpendicular lines. Okay, perpendicular lines are lines that intersect at a right angle. So they have 90 degrees. So I can do better than that. If I have a straight line, right, like this, and actually let's make it more at an angle, right? So parallel lines don't have to be strictly up and down or perpendicular. I mean, as long as they cross at that right angle, I can have 2 lines that are perpendicular, even if the lines themselves are not perfectly vertical or perfectly horizontal. Okay, so the symbol for perpendicular lines is an upside down capital T, just as so. And then here, perpendicular lines have opposite reciprocal slopes. So what that means is, like as an example, if one of these lines has a slope of 3/4, okay, then the opposite reciprocal, so we can say the perpendicular, right, because that's the symbol, slope, would be the reciprocal, which so I flip the fraction. And then opposite means that I make it negative since this was positive. If this one's positive, then it would become, or if this one's negative, then it would become positive. So you just flip the sign and you flip the fraction. So the opposite part is the positive negative, and then the reciprocal part is the flipping of the fraction. Okay, I'm gonna have to clear this so we can go down to transversal and some other ones. Okay, so a transversal is a line that intersects two or more lines. So let's say if I have a line, another line, right? They're not parallel or perpendicular here. But if I have a line that cuts through them, this line right here is the transversal. And that's going to be really important because we're going to deal with a lot of properties that involve a transversal, okay? And it doesn't have like, I could have 3 lines. If there's a line that cuts through, again, that's the transversal. You can't fit it, but there you go. Okay, so it's a line that cuts through 2 or more lines. Hopefully that makes sense. Okay, so the next 4 terms that we're going to talk about here, I'm going to be using multiple colors for. So if you have multiple colors, it would probably be pretty helpful here. And I wish that I could draw in black, but I can't do that. So we'll make it work. Okay. But the next 4 terms are going to be only relevant if we have parallel lines. Okay, so the next 4 terms that we look at only works if we're talking about parallel lines. Okay, so this is the darkest color I have. So if I have 2 parallel lines, I'm not, right, and I know they're parallel. I'm gonna draw the little arrows so I know they're parallel. Okay. So corresponding angle says in parallel lines, corresponding angles are angles in the same position as each other. So I need 2 parallel lines and I also need a transversal. Okay, so what this is, and we're just gonna start picking some colors here, lines that are in the same position. So let's look here. If I draw this angle is to the left of the transversal, right? Here's the transversal. It's to the left of it, and it's above the parallel line. So then I'm going to come down here, and I'm going to say what angle is to the left of the transversal and above the parallel line, just like this one is. And that would be this angle right here. Okay? So those two angles, are corresponding. Okay, the next one, if I draw, let's say this angle, that angle is to the right of the transversal and above the parallel line. So that corresponds with this angle right here, right? To the right of the transversal and above the parallel line. So those 2 angles are corresponding. Same thing if I'm talking about this angle, right? It's to the left of the transversal, but below the parallel line. So then that would correspond with this one, to the left of the transversal, below the parallel line. And then lastly, the green is to the right of the transversal and below the parallel line. So that's corresponding to this one. So if I go through And I label these like 1, 2, 3, 4. Actually, no, it's fine. And then 5, 6, 7, 8. Okay, so 1 and 5 are corresponding. So angle 1 and angle 5 are corresponding, right? Angle 2 and angle 6 are corresponding. So if you are not using colors, this is a good way to stay organized here. Angle 3 and angle 7 are corresponding, and angle 4 and angle 8 are corresponding. So these are all my corresponding angles. So hopefully we feel good about that. Moving on to alternate exterior angles. If I have two parallel lines, parallel lines in a transversal. I'm just going to draw similar images every time, but know that it works for any transversal, okay? Alternate exterior angles are angles that are on opposite sides of the transversal and outside the parallel lines. Okay, so if, first of all, it's outside the parallel lines. So this is outside the parallel lines, right? It's on the outside of them, not the inside. So on the outside of the parallel lines and on opposite sides of the transversal. So this one's on the left side of the transversal. So then this would be the alternate exterior angle, since it's on the right side of the transversal, but still also outside of the parallel lines. So one's on the left, one's on the right, but they're both outside the parallel lines. So these two angles are alternate exterior angles. Similarly, this angle is on the right side of the transversal. So the alternate exterior of that would be over here. And if I go to, that's a little too purple. If I go to label these like 1, 2, 3, 4, then angle 1 and angle 4 are alternate exterior angles. And angle 2 and angle 3 are alternate exterior angles. So hopefully we're feeling good about that. Moving on to alternate interior angles. So again, here's my parallel lines. Another parallel, because I'm going to draw my little arrows. And let's have my transversal going this way, because why not, right? All right, so now we're looking at alternate interior angles. So in parallel lines, angles that are on the opposite sides of the transversal, so one on the left, one on the right, and inside the parallel lines. So now we're looking on the inside, in here, okay? So if this is one of my alternate interior, see how it's on the inside of the parallel lines, right? It's in between the parallel lines, and it's to the left of the transversal. So then my other one would be over here, to the right of the transversal, but still inside those parallel lines. And then using that same idea, if this is one of my angles, it's to the right of the transversal, so my other alternate interior is going to be to the left of the transversal. And same thing if I label these 1, 2, 3, and 4, then angle 1 and angle 4 are alternate interior angles. And angle 2 and angle 3 are alternate interior angles. Alternate interior angles are something that we use all the time. All the time. Same thing with corresponding, okay? So make sure that we're feeling pretty good about those. I'm going to clear this. We have one more definition, and then we're going to go into, oh, I'm a big fat liar. I'm not doing, Just kidding, no more. Okay, so that's going to be it for terms. So then let's go down to postulates, theorems, and formulas. Let's talk about these. So how many of these do we have? Maybe 4 of them today. We'll see how we go. Okay. First one, same side interior angles postulate. So this is one that we didn't actually go over in the terms, but it's all good. We'll get it going, right? So same side interior angles is sorry. Let's do this. So same side interior angles are supplementary. Same side interior angles are supplementary. This means that they add to 180 degrees. Okay, they add to 180 degrees. So if I draw my diagram, wants my diagram over here. So if I have 2 parallel lines, there's one, there's the other. Beautiful. And I know these are parallel. We can draw our arrows. The pin's getting jumpy. It won't let me draw arrows. There we go. Okay, same side interior. So let's think about that for a second. Same side. So they're on the same side of the transversal. So here's one. And they're on the interior. So they're inside the parallel lines. So do you see how both of these are inside the parallel lines? Okay, I'm going to call this angle 1 and this one angle 2. Okay, and so they're on the same side of the transversal and they're both inside the parallel lines. Could I have done it over here too? Sure. I just chose to do it on the left side. Okay, and so what this is telling us is that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Okay, so for my same side interior angles, my green angle plus my red angle is 180 degrees. Okay. For alternate interior angles theorem, we can say that alternate interior angles are congruent. So if we have alternate interior angles, which we defined on the previous page, right? If we have alternate interior angles, then those angles are congruent. So let me show you if I have parallel lines. And here's another one. Ooh, those are not the best parallel lines, huh? And then here's my transversal. Okay. Alternate interior angles. So going back inside of the parallel lines, because it's interior, and one's on the left and one's on the right. So this guy and this guy. So if I call this angle 1 and call this angle 3, then we can say the measure of angle 1 equals the measure of angle 3. Okay, they are the same. So if they are alternate interior, they are the same. Okay, next one is corresponding angles theorem. So we can say that corresponding angles are congruent. Corresponding angles are congruent, meaning if there are angles that are in the same position, they are congruent. So here's the parallel line. Remember, corresponding angles, we're looking at parallel lines here. Okay, so if the lines are parallel, the angles are the same. Here's a transversal. I'm going to call this angle angle 1. And then I'm going to call this angle angle 5. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay. So they are in the same position. They are both to the right or above the transversal, and then to the left or above the parallel lines. So they are in the same position. So that tells me that the measure of angle 1 is equal to, a little too purple, huh? The measure of angle 5. They are the same. So if you have corresponding angles within parallel lines, they are the same angle measure. Oops. And last one is the alternate exterior angles theorem. Same idea, right? If I have parallel lines, alternate exterior angles are congruent. Keep in mind, this is only happening if I have parallel lines. If I don't have parallel lines, they're not congruent, okay? So then last example, parallel line, transversal. Alrighty. Oh, parallel. Okay, last one. If I have this angle, let's just say is angle 2. You see how it's to the left of the transversal and on the outside of the parallel lines? That's what I'm looking for. But now I need to go to the opposite side. So the right side of the transversal and under the parallel, still outside the parallel line. So I'm going to call this one 8. Okay, so this tells me that the measure of angle 2 is equal to the measure of angle 8. Again, only if these two lines are parallel can we say that. Whoosh, that was a lot, right? A lot of terms, things like that. So we're going to go back up to 2-1 notes, and we're going to do a couple of practice problems together, and then you guys will try some, and it'll be a whole lot of fun. So go ahead and go to that first page, and then we'll get started. Okay, so we're back here at section 2-1. We're going to start here with example 1, and it just wants me to identify the pairs of angles of each angle type made by these snowmobile tracks. So what that means is identify the corresponding angles. So which angles are corresponding? Then identify the alternate interior. Which ones are alternate interiors? Then we're going to identify the alternate exterior. Wow, I can spell. There we go. Sorry. Then we're going to identify the same side interior. Okay, so I want you to try these, and I just want you to write down which angles are corresponding, which angles are alternate interior, which angles are alternate exterior, and which angles are same side interior. So go ahead and give it a try, and then go ahead and hit play when you're done, and we'll check our work. All right, so let's check our work here. Corresponding angles. I'm just going to start with angle 1 because it's easier. So angle 1, and then the question is, what angle does 1 correspond with? Well, angle 1 is to the left of the transversal and above the parallel line. So then over here in this group, I want to the left of the transversal and above the parallel line, which gives me angle 5. So angle 1 and angle 5 are corresponding. If I move on to angle 2 is to the left and below. So over here to the left and below is angle 6. So those are corresponding. Then I have angle 3, which is to the right and below. So over here in this group, that would be angle 7. And then lastly, we have angle 4, which is to the right and above. And that is corresponding to angle 8. So there's my 4 corresponding pairs, right? Alternate interior now. So I'm only looking at numbers inside the parallel line. So I'm not looking at these guys at all. I don't care. Those are outside. Don't care. Okay, so angle 1 is to the left and inside. So the alternate interior would be to the right and inside, which is 7. So angle 1 and angle 7 are alternate interior angles. And then vice versa, angle 4 is to the right of the transversal. So up here I need to go to the left, and that's angle 6. So hopefully that's making sense. Next one is alternate exterior. So I'm only looking at angles that are exterior. So I don't care about these guys at all. Okay, so angle 2 is to the left. So in this group up here, I want to go to the right, which is 8, because I want the alternate side. So angle 2 and angle 8 are alternate in exterior. Okay. The next one is angle 3. And angle 3 is to the right of the transversal. So up here I want the left, so I get angle 5. And then last, but definitely not least, is same side interior. So again, interior. I'm only interested in the interior. And I want same side. So angle 1 is to the left of the transversal, and I want the same side, right? So that would be angle 6. And those are the only ones. They are not equal to each other. They add to 180. And then same thing, angle 4 is to the right. And so up above, that is same side interior with angle 7. So get all that down. Hopefully that makes sense and we're feeling good about it. Let's do a try it here. So I want you guys to just try it. Which angle pairs include the named angle? Meaning, what can I say about angle 4 with angle 2? What can I say with angle 4 about angle 8? What can I say about angle 4? So just write down every single relationship that you see that angle 4 has with any of these other angles. And then we'll check our work here in a second. Okay, so if you're getting stuck, go ahead and just wait for a second so that I can kind of get you started and then hit pause and go, okay? Okay, so the first thing that I see here is that angle 4 is corresponding with angle 8. So I can say angle 4 and angle 8. And I'll just say corresponding. Okay. I also see that angle 4 and angle 2 are vertical. So I'm going to write that. Angle 4 and angle 2 are vertical. So do you see what I'm doing? I'm just writing down what is the relationship with all of the different angles with angle 4. Okay, so do you see, I see angle 4 and angle 5 are alternate interior. So angle 4 and angle 5 are alternate interior. What else do I see? I see 4 and 6 are same side interior. Angle 4 and angle 6 are same side interior. And then I see that angle 4 and angle 3 are supplementary. But I also see that 4 and 1 are supplementary. So I can write down either one of those or both, right? Supplementary. They add to 180. And that's kind of all I see with angle 4. I already know it's vertical, it's supplementary to 1 and 3. Corresponding, same side interiors, alternate interior. And so that's what we're looking for, okay? So go ahead and hit pause and then do or part B and see if you can come up with all the different ways that, or all the different angles that are related to angle 5. Okay, so angle 5 here, I'm gonna write up here, it's right here. So I see that angle 5 and angle 2 are corresponding. They are in the same position, so they are equal. I see that angle 5 and angle 8 are vertical, so they are equal. Right? They're across from each other. I see that angle 5 and angle 4 are alternate interior. Let's see, I see that angle 5 and angle 3 are same side interior. Remember, that means that they add to 180. They are same side interior. And then I see that angle 5 and angle 6, as well as angle 5 and angle 7, are both supplementary. They add to 180. They add to 180. And I think that's it for angle 5. Pretty sure. So let's move on. Hopefully that feels good. Again, if it doesn't, make sure that you reach out to your teacher so you can be getting help on this, okay? Don't just sit there lost. It's easy to get frustrated if you're not getting help when you need it, okay? Okay, so for example 2, it says, how can you express each of the numbered angles in terms of x? So here's your x right here. So I'm just going to make a list. Angle 1, angle 2, angle 3, angle 4. I don't have a 5. Well, I guess I do. Angle 5 we know is x. Angle 6, angle 7, and angle 8. Okay, so I'm going to go through. I know that this is x. So things that I know are going to be true. I know that 1 and x are corresponding. They are in the same position. Since they are corresponding, they are the same thing. So angle 1 is also whatever x is. Angle 1 is also x. Okay. Then I see that 1 and 3, these are vertical from each other, so I know that they're going to be the same. So angle 3 is also x. Okay. Then I see 7 is vertical from angle 5. right? So 7 and x are going to be the same. So this is x. And I guess it should have degrees, right? We don't know what the degree is. Okay. And I think that's all. This is x and this is x. I think that that is all that I know of x. Now, let's look at just these two angles. These two angles right here make this straight line, right? We all see the straight line. Well, the measurement of a straight line is 180. So I know that x plus angle 6 equals 180, right? Whatever this angle is plus this angle equals 180. And I want to solve for angle 6. So I'm going to subtract my x, and I get angle 6 is equal to 180 minus x. So that's what angle 6 is, 180 minus x. Okay, great. If that's 6, well, 6 and 8 are vertical. So they're the same thing. So that tells me that 8 is also 180 minus x, because they're vertical from each other. And 6 and 2 are corresponding. They're in the same position, which means they're also equal. So that means that 2 is 180 minus x. And then lastly, 4, 2 and 4 are vertical from each other, right? They're across from each other, so that means that 4 is also 180 minus x. Whoosh! Okay, so now you guys are going to try it yourselves with a number, though. I'm given that angle 4 is 118, and I want to find the measure of each angle. So angle 1, angle 2, angle 3, angle 4, and then 5, 6, 7, and 8. I'm told that 4 is 118, so that's wonderful news, right? So now I want you to go ahead and hit pause in the video and see if you can come up with the other 7 angles here. There we go. So let's review these. Angle 4 is 118, so angle 2 is vertical from that, so that tells me that angle 2 is also 118. 4 and 8 are corresponding because they're in the same position. So 8 is also 118. And then 6 is vertical from 8. So 8 and 6 are also the same. So this is also 118. Okay, so now we're looking at what about like 8 and 3? Okay, 8 and 3. I know 8 is 118. Right? And 8 and 3 are same side interior, and those add to 180. So if I do 180 minus 118, I get 62. So that tells me that angle 3 is 62. 3 and 1 are vertical from each other, so 1 is also 62. 3 and 5 are alternate interior angles, so that is also 62. And then 5 and 7 are vertical from each other, so also 62. So 4 of my angles are 118, 4 of my angles are 62, and we found the measurement of every other angle. Okay, one more I want you to try. So right here, try it. It says parallel lines are intersected by a transversal. Find the measure of the other angles if angle 2 is 58. So this right here is 58. And I go ahead and find all the other angles, and I'm going to go ahead and hit pause. And when you are ready, hit play and check your work. Okay, so check your work here. Make sure everything looks good. I got the angles 2, 3, 6, and 7 were 58. And then angles 1, 4, 5, and 8 were 122 since they're supplementary. They add to 180. Okay, so we're going to stop the video here at the end of example 2, and our next video is going to do examples 3, 4, and 5. So take a break if you need to, right? Do whatever you got to do. And then our second video is going to do examples 3 through 5, and that'll finish out our lesson 2-1.